For the modulated signal xt is equals to mt cos 2 pi fct, the message signal mt is equals to 4 cos 1000 pi t and the carrier frequency fc is 1 MHz. The signal xt is passed through a demodulator as shown in the figure below. The output yt of the demodulator is, for this question, we have been given 4 options out of which one of them is correct. The NPTEL video reference for this question is Lecture 17 Analog Communication by Professor Gautam Das from GS Sanyal School of Telecommunication, IIT Kharagpur. Some useful information required to solve this question. We begin with the definition of modulation, the conversion process in which a baseband signal or a message signal is used to modify some parameter of the carrier signal. Baseband signal is an unmodulated signal having low frequency components. Amplitude modulation is the process in which amplitude of carrier signal is modulated or modified by the message signal. In the given question, xt is an example of amplitude modulated signal because the term which appears before cosine, which is the message signal mt in this case, is its amplitude, and as mt changes with respect to time t, the amplitude of this signal changes and hence it is an example of amplitude modulated wave. Demodulation is the process of reconstructing the original baseband signal at the receiver. The simplest demodulator is synchronous detection or coherent detection, where the carrier of exactly same frequency and phase is used at the receiver. When the carrier used in demodulation at the receiver has some phase offset, then it becomes difficult to generate the original baseband message signal. The block diagram given in the question is an example of synchronous detection with phase offset because when we compare this signal with the original carrier signal, which is, then we see that between these two signals there is a phase difference delta phi of 2 pi times 40 radians. Some important formula we will require in this question is Fourier transform of cosine signal can be written as 1 by 2 times delta f minus fc plus delta f plus fc, where delta is the impulse function. The frequency spectrum of cosine signal can be shown as two impulses at plus fc and minus fc respectively and taking the amplitude of half. This block shown by a cross is called a multiplier, and at the multiplier output here we see the product of these two signals take place. We can write the output at multiplier as, by substituting xt is equals to mt cos 2 pi fct in this equation, we get, applying the formula for cosine, which is cos a times cos b is equals to 1 by 2 times cos a plus b plus cos a minus b in this expression. By putting 2 pi fct as a and 2 pi fc plus 40t as b, we get substituting mt is equals to 4 cos 1000 pi t. In this expression, we get simplifying this expression, we get we can write 1000 pi t as 2 pi times 500 t. Again applying this formula of cosines in this expression, we get we label this equation as equation number 1. What we see is, in this equation there are 4 cosine terms, and according to the question We need to pass this 4 signals through a low pass filter with cutoff frequency of 510 Hz. The Fourier transform of cosine signal gives two impulses at its respective positive and negative central frequencies. Calculating the Fourier transform of above expression, we see that in the first term has a frequency of 2fc plus 540, and since fc is equals to 1 MHz, it has a very high frequency of 2 MHz plus 540 Hz. So it gives two impulses which lie outside the window of the low pass filter. In the second term, we see it has a frequency of 2fc minus 460. Again, since fc is equals to 1 MHz, it gives two impulses which lie outside the window of low pass filter. This cosine signal has a frequency of 540 Hz. Since the window of the low pass filter is restricted to 510 Hz, again this impulse lies outside this window. The last expression we see has a frequency of 460 Hz. Since it is less than 510 Hz, it is passed through the low pass filter. Since only this signal, having a frequency of 460 Hz, is passed through the low pass filter and all the remaining signals are blocked, so we can say yt is equals to, or equivalently, so the output of the demodulator, which is yt, is cos 920 pi t, which was asked in the original question. So the correct answer to this question is yt is equals to cos 920 pi t, which is option B.